In this exercise, we are required to determine the current in each branch of the network shown here. We can solve this problem by using either Kirchhoff's voltage law or by Kirchhoff's current law. Here, Kirchhoff's voltage law is a method which is given everywhere. So, I'll solve it by using Kirchhoff's current law. I'll leave Kirchhoff's voltage law method at your own level to solve, and that will also be relatively lengthier. And in KCL method, I've already explained you in theory lectures that first we distribute the potentials in circuit. So if this is a 10 volt battery, we consider on the negative side, if we consider the potential to be 0 volt, on the other side the potential will be taken at 10. Here if we consider potential as X, here if it is 0 at point C also potential will remain 0. And by symmetry of circuit we can see if a current I is flowing through the battery, it is dividing in 10 and 5 ohm. And finally this combining in 5 and 10 ohm only. So by symmetry we can consider if at point B potential is Y, at point if this point is D, here potential we take as X minus Y by symmetry. So if we write KCL equation at junction B. Here for junction B there are 3 wires connected. So the sum of all 3 currents flowing in these 3 resistances must be 0. So here the current flowing is Y minus 0 by 5 plus current flowing in this direction is Y minus X plus Y. So this will be 2Y minus X by 5 plus here current will be Y minus X by 10, that should be 0. And simplifying this equation, we can get this will be 2y plus 4y, 6y plus 1, 7y minus 3x is equals to 0, which is giving us y is equals to 3x by 7. This is one equation we are getting by writing KCL equation at junction B. Now if we write KCL equation at junction X or at junction A, we can write here also there are 3 wires connected at A. So we sum up the 3 currents and equate it to 0. So current flowing in this direction will be X minus Y by 10 plus current flowing here will be X minus of X plus Y. So this Y by 5 plus here current flowing will be X minus 10 by 10 should be equals to 0. If we simplify this equation, this is giving us X and X, this 2X plus 2y minus y plus y is equals to 10. This is equation 2 we are getting, and now from 1 we can substitute the value of y over here. So this 2x plus 3x by 7 is 10. So this is becoming 17x by 7 is equals to 10. And which is resulting as the value of X to be 70 by 17 volt. If we are getting the value of X as 70 by 17 volt, this implies the value of Y is 3 by 7x. 3 by 7 times 70 by 17, which is 30 by 17 volt. So we have obtained the values of X and Y. That means at all terminals we have got the value of potentials. So if we calculate the current in all the branches, so first let's calculate the current in branch AB. So in branch AB the current we can write as X minus Y by 10, that is by Ohm's law. So X is 70 by 17, Y is 30 by 17, so 70 minus 30 is 40 by 17 by 10, so there's 4 by 17 ampere, there's one result. We calculate the current in branch BC. So obviously this is Y minus 0 by 5, this is Y by 5, and Y by 5 is 30 by 17 upon 5, 6 by 17 ampere. If we calculate the current in branch BD, then current in branch BD is given as y minus of x minus y. So here y is 30 by 17, x minus y is 40 by 17. That means current will be flowing actually in upward direction. So arrow drawn over here is wrong, because the value of y is, you can see the value of y is 30 by 17 volt and x minus y is 40 by 17 volt, and current always flow from high potential to low potential. That means current would be flowing in this direction. This is wrong. So here the current flowing in branch BD is from D to B, and this 40 by 17 minus 30 by 17, 10 by 17 by 5. So here the value we are getting is x minus y is x minus 2y by 5. So the value we are getting is 2 by 17 ampere. If we calculate the current flowing in branch AD, then it can be again given as x minus of x minus y, this is y by 5. So this is also 6 by 17 ampere. And current in branch DC is also, we are getting x minus y by 10. So this is 40 by 17 by 10, this is 4 by 17 ampere. Plus if we calculate the current through battery, so current through battery can be given as, in this equation, this 10 minus x by 10. So the value of x we are having is 70 by 17. So 10 minus 70 by 17, here you can see current through battery is 10 minus 70 by 17 by 10. So the value we are getting is this 170 minus 70 is 100 by 17 by 10. So this 10 by 17 ampere. So these are the all results for this problem, the current through all the branches of the network shown here.